Ladies and gentlemen, hello and welcome to today's Partner Web Conference. This is Fast Track for Dynamics 365 Finance and Operations Tech Talk. Today's topic, Acceptance Test Library. My name is Janice and I'm going to be your moderator today. We are broadcasting this web conference through Teams live events and the audio can be heard through your PC speakers. Today's web conference is being recorded on behalf of the Microsoft Corporation. If you do not consent to be a part of a recorded session, we ask that you please disconnect now. Attendees may access the web conference recording within 72 hours via the same registration link that was used to attend today's live broadcast. If you have questions for the presenters or need support, you can turn on the Q&A panel by selecting the question mark icon located in the upper right-hand corner of your screen. We do have presenters standing by to answer your questions throughout the session. Now, moving on to the presentation. Presenting for us today from Microsoft, we have Senior Software Engineer Davorin Ban. So without any delay, Davorin, welcome and thanks for joining us.
Hello, everyone. Thank you, Janice, for the introduction. So as Janice mentioned today, I'm going to present and kick off the acceptance test library framework. We've been talking about it in some previous ISV workshops and announcing it previously. So today we will present it and explain what this library is all about. So with that, I will first start with what is ATL framework. One thing I wanted to mention first is that, as Janice mentioned, feel free to ask questions in the Q&A area throughout the presentation. We have two moderators that will answer them all along. So first, I will explain a little bit about the framework and some of the benefits, the value that you would get by using the framework itself, and then I will jump into a couple of demos. The first demo, I will explain all the main concepts of the ATL. And then in the second demo, I will explain the ATL wizard. This is the code generation tool that we use for you to auto-generate these objects for the ATL. So what is ATL framework? So it stands for Acceptance Test Library. It's a test framework that we use here in the Finance and Dynamics 365 for Finance and Operations teams. It's a standardized and uniformed approach for addressing any data needs that you have in your test automation. Be one single data setup for one test, or data setup for a whole test class, or if you want a more broader test data setup for the whole feature, or a set of common test classes. Well, you can definitely use ATL to do that and centralize all that data setup that you need throughout the tests. ATL is also used for validation area, so validation aspects of your tests. And if you have to do any data querying inside your tests, you can use that. You can use ATL for that as well. It's a 5-year-old mature framework, so we already been using it internally for 5 years, and it's provided to us many benefits. It's in terms of stability, in terms of reliability, and other aspects. I will briefly touch on why testing is important. That should be self-explanatory today. We need a fast quality feedback loop, especially in today's day and age of continuous integration, continuous delivery aspects. So our tests need to be fast, they need to be reliable, and if they fail, we need to be precise and know exactly why it failed and what's the failure and how to fix it. So these are some of the attributes that this test suite needs to have in order to achieve those goals. So reliability, maintainability, speed, simplicity, and preciseness. How does ATL stack against those? Well, it improves maintenance because when tests fail, we have clear failures, and it's minimal to understand, and minimal failures as well, because it's very clear to understand what's failing. Typically, that's in the validation area, and you have a set of actual and expected when if you're validating transactions, for example, or validating state of data in the end of your test. You have an actual list, you have an expected list, and you can easily understand what's failing, and it's fairly consistent that way. It improves simplicity. Well, ATL APIs in themselves are very fluent. Fluent means you can chain them together and to get a more descriptive understanding of what data you're using. You don't have some obscure abstract helper classes which don't promote readability in your tests. They use domain terminology, so all these APIs basically use domain terms that you can find in the application itself, so that it should promote familiarity that way as well. And they're very well categorized. So, for example, if you're searching for data that you need for within a sales area, you would intuitively search for sales domain, and then inside of sales orders or other sales concepts within that domain. It's a one-time creation, which means you just create it one time, and you don't have to worry about doing anything with it going forward, unless you just add a certain fields or you extend your table or etc. Then you can just update it quickly through a wizard to add those newly added fields. And it improves flexibility because it gives you a lot of control and as to what data you can use. We have defaults for any data in the system, but if you want more control and you don't want to use those defaults, it certainly gives you that as well. It improves preciseness. So we have a built-in validation mechanism. I briefly mentioned it earlier. That's what ATL specifications concept will give to you. It will clearly define your expectations in the test, and it has consistent failure messaging in terms of actual versus expected. So your expectation and versus what actually you are encountering the system at that point of the test. You will be able to easily compare these and figure out what's the issue. It improves speed and reliability. So ATL is built upon product APIs directly, and it abstracts those for you. And internally, like I mentioned, we've used it for quite some time now, and it's proven for us to be quite reliable from that standpoint. So in total, all of these things, they amount to significant reduction of test development and the effort that we have to partake in improves our productivity. Test categorization, for those of you that have been in previous workshops, and this slide might be familiar. What this is a pyramid that's fairly standard in today's testing, and it starts with the unit tests, where on the bottom we have the biggest chunk of the test pyramid is unit tests. So the way these types of tests are structured is based on granularity and based on how many tests you would have. So at the bottom, unit tests are the most granular tests, and you should have most of those tests in your test bed. And the reason being because they are the fastest to execute. So then you have component tests. There's a little smaller number of those than unit tests, and they test on a feature area, so they're less granular than unit tests are. On top, further up, you have integration tests. You have even fewer of those. Here you're testing more than one feature, so multiple features together and how they integrate. You're not using any mocking. You're using direct code to do those. And then further up is business cycle tests. Those are end-to-end tests of the system. Those are basically very, very high-level tests that you should have the smallest number of those. In our application, it also we also distinguish as to the author, as who's authoring these tests. So the more granular tests typically will be done by the developer itself, who's writing the code, and the user will use recording tools to record some higher level tests. Where does ATL stack in here? Well, ATL is best positioned against component tests. However, and that's its sweet spot. However, if you need any data needs, if you need to set up data for unit tests or set up data for integration tests, it can also fulfill those needs as well. And you can use it there. With that said, ATL integrates well with the existing frameworks that we have. So Form Adapter is a framework that we use for UI automation. It's also freely available. And the SysTest is the SysTest framework used for our test automation. As you can see an example here, you can easily integrate ATL with those two frameworks. Here we're using ATL to arrange, to set up some data needs that we want, and you can use those objects then in your form adapter, so your form automation. In UI, where you're invoking some form, you can actually use those objects created through ATL abstractions in your UI test, and then finally you can use SysTest to validate those things. So you don't have to use ATL for validation if you don't want to. You can use SysTest directly as it's being used without ATL as well. So if you want to integrate with the other frameworks, you're more than welcome to do that. So what are the main concepts of the ATL? Well, the first are data classes. These are the main category classes, and the purpose of those classes is to host entities. So to give you some default data, to give you some data or some entities where you want to set up your data. If you don't want to use the defaults, you would have to you would navigate to those through domains, through the data classes. We have two levels: domain data classes and then feature data classes, and they exist there to kind of descriptively show and express where this data resides, so that improves readability, improves maintenance for whoever's maintaining your test after you have written it. Second are entities or creators. They are application entity abstractions in the simplest term. Simply put, it's usually abstracted on a table, and that's what mostly you will see entity built upon. And as I mentioned up top, they are hosted by the data classes. Then you have queries. So basically, queries are objects that allow you to query over entities. So let's say you have multiple sales orders and you want to query for one that has a specific customer or has specific lines, you would use query to kind of distinguish and use which one to use, right? Specifications, I mentioned it earlier. These are objects that allow you to define your expectations inside the tests. In the validation area where you would typically use them, you would combine them with a query. So for this query, give me these lines, and for each of these lines, I want to validate this expected behavior, that each line has this quantity, this status issue, this value has posted, etc. Commands, they are entity business operations. They reside on the entities. They represent business logic. So anything that you can do with this entity. For example, I have a sales order or a purchase order. I can post a product receipt on this purchase order. I can invoice this purchase order. I can add lines on this purchase order, etc. Those are some of the examples of business operations. With that, I will step into the first demo where I will actually explain in code all these concepts so that it actually solidifies in your mind a little bit what that is. So first thing I want to point out is on the left side, you can see many models that consist of this acceptance test library. The three most important ones that I want to highlight is the ATL Foundation. That's the model that contains all the framework pieces of the ATL framework. The ATL application suite, that is the model that contains all the entities, queries, and other ATL objects in relation to application suite objects. So application suite tables, application suite mainly tables. You will find entity for those inside the this acceptance test library application suite model. And the third one I want to highlight is this acceptance test library sample tests. That one contains the sample tests that we have generated from our domain for you to refer to see how certain tests should look like, so that you have some idea on how to go about automating. If you expand the code area, we have 5 sample tests already added here for you to explore. We plan on adding more of these, but these are basically our internal tests that we have exposed as examples that you can use, and they're very, very well documented as well. So here I already have a sales order sample test open. So we'll go through that in more fine-grained detail to explain all the ATL concepts and how to use this framework. So first thing I want to mention is this: every time you extend the sys-test case, that becomes your test class, and it's using sys-test framework. I want to mention that this will run on an empty data set. So that means when you invoke any tests inside of this class, they will run on an empty data set. There will be no data behind the system. So you're basically running on a blank state. With that said, the next thing I want to highlight is the ATL data root node class. The static construct method on that class is your navigational entry. So it's your main entry into the ATL framework. By instantiating that class, you are starting to, you're entering the ATL framework. And then, so I mentioned the data classes concept. So you can see here, they all are prefixed with ATL data. So all of these ATL data star classes are data classes. So they are all hooked into the main data root class. So that's how you would then navigate and expose to those. And I briefly mentioned that the way you start these is first you have a domain level set of data classes, and then each domain level data class has a set of feature level data classes. So that's how you would navigate this tree. Is you would use this data root node, and then on a data root node you would expose the domain you are interested in to get the data from. So in this case, we're using invent domain, which is inventory. And inside the invent domain, then you can expose and invoke various different feature level data classes, or so data that's interested in particularly for the inventory domain. So as you can see here, we're using here the on hand. So we're interested in item availability here. You can also use transactions, so inventory transactions. We're just putting these into separate variables so that we can refer to them later. And items. So you can see how it's built quite intuitively. So items reside in inventory, so that's how you would invoke to them. So I would request, give me inventory domain and give me items inside the inventory domain. This is the feature. Again, what are data classes used for? They're used for us to get to some defaults or to get to some specific data that I want to set up. So that's the whole purpose of the data classes. And they have, like I said, 2-level hierarchy, and that's done for you to improve readability so that you can know exactly where the data is coming from, where data is flowing. You would use these Fluent APIs that way in these data classes. So here again, we have another data class. In this case, this is the base sales domain data class. And from sales domain data class, then I'm using, again, further feature level data classes. In this case, sales orders, sales order lines, and sales order packing slip journal lines. For this particular test, I will care about sales orders and their lines and packing slip journal lines. So you can find them all inside the sales feature level data class. Also the invoice lines as well. So that's how you would get to some of these data classes on the feature level. Then we go one level in deeper. So here I have invent data class for the inventory domain. Sites are the sites feature inside the inventory data class. And then here I'm calling the default. As I mentioned, the whole purpose of using these data classes is to get to some data. And default is the way to do that. So each of these data feature level data classes will have some default API in one shape or another. For example, either calling directly default, you can see it has an optional parameter. So if you want to specify some site ID, you can do that, or some ID, similar to the warehouse as well. Or so it will be one or the other flavor of some default API that you can use. Of course, some more complex entities, such as costing version, will have multiple different defaults for you to use. So let's say that you care about standard costing version or a planned costing version. Well, you have defaults for specific type of costing version as well. So that you don't have to control it, you can actually just call default as well. Important to note, when you call default, it actually will create data behind the scenes and persist it into the database for you. If you pass it with an optional parameter, it will use a constant inside the ATL API. Otherwise, you can pass in the ID that you want to use. So, and like I mentioned, when you call the feature level data class, the next call inside that, it's always some that entity, unless it's some master data that we call directly, will give you a buffer back. So here we have a more involved example. So again, I'm in inventory data area class. I'm looking for prices. This is the feature that I'm interested in inside the inventory. And here I want to, and the next call will be always an entity, right? So here I want to control how my entity is created. I'm not satisfied with just the default. So I want to control what the price I want to save. This is how you would do it. You would call some form of initialization init class on it, and then you would set specific fields that you care about. For example, in here, I'm initializing costing price. I'm setting specific version. This is the version I passed from the master data area above, specific item, and then specific price. And then I'm calling a save on that. When every time I call a save after I've manipulated the object, it will persist the data for you. And then I can also fluently combine the command as well. I don't have to, but this is kind of a nice way to do that. Calling activate is an example of a command. What that will do is will actually go and activate my standard price. So I have created a pending price, and then by calling activate, I'm activating that price for that particular item I created above, for the costing version I created above. We have again a similar example here for the catch weight item. So here I'm using the data feature level data class on the items that I've instantiated before. The next call on the feature level data class, it is always an entity. So here I'm using the items entity, Acro's release products entity, and again, I'm not satisfied with the default here. I want a specific item back that has a specific tracking dimension group, specific unit, and here I'm passing in, it's the data invent domain units featured data class, And then inside the units, I have a bunch of other defaults, in this case, pieces. And then I can also use kilograms. These are just defaults for specific the specific unit that you want to use. But so I'm setting a catch weight unit, setting a unit of measure, and then I'm setting many other things like nominal quantity, minimal quantity, maximal quantity. These are these are the quantities related to the catch weight items, something specific to catch weight. So, and I care about in this instance for setting those. So you can, so that's why I'm setting them here. I'm calling a create. Again, it's either a save or create variation. What this will do is actually go and save and persist this type of item inside in the database. So you can see how it becomes quite descriptive and expressive using these APIs on creating some data in the system. So the next person that goes in kind of analyzes this test can clearly see what kind of item I have in the system. There's no some helper with a bunch of parameters passed in. It's obscure and not readable and not understandable what kind of item I'm using. It's all very descriptive for you presented, and that was our main one of the main guiding points of this framework, to be quite descriptive, so that even a non-engineer can understand what's happening. So this was all part of the setup. I've set this up in the setup part of the test, so that my whole test class can use this and reuse this data. So then I go into the test itself. So here I'm creating a sales order. Sales order is again a data class that we passed into a variable above, and I'm calling a default. So what's the call? The next call on a data class is always, as I mentioned, an entity. And so here I'm grabbing a default entity. I don't care about any specifics on a sales order, just give me a default entity and it will do that for you. We have APIs and other methods where you can pass in a customer. Let's say you care about what customer I want to create a sales order for. You can do that here as well. So it kind of, the other guiding point was that we want to mimic and imitate how our application suite or how our application is creating these so that you can actually use this library in that way as well. So I created my sales order here. So the next thing I'm using here is I'm creating a sales order line. So here I'm invoking, so it becomes pretty intuitive, right? So here I am adding a line. This is in a business, this is a command. It's our business operation. And one of the operations you can do on a sales order, you can add a line. It will give you back the sales order line entity. And in this case, I don't want just a default one. I want to set some specifics about this line. In this case, I want to give it a specific item, a specific quantity, a specific unit price, and a specific deliver now quantity, which is packing slip, the constant I define here. And of course, I want to set up some inventory dimensions, some dimensions that are related to this item. And we have a specific set invent dims API that accepts the container. And accepts a very different types of dimensions here that you want to specify. Here we're passing the warehouse. It's important to note that we have the defaulting capability, just like in that you would see in the application itself. So once I specify the warehouse, the warehouse, of course, knows what site it belongs to, so it will default that information for you. So you don't have to be redundant and specify that for it itself. So this is, again, an example how we actually are imitating and simplifying the framework to be used just like the application is used. Again, I'm calling save here. That will save this sales order line in the backend for us with these specific objects. Again, it's quite expressive, quite descriptive, and how this object is created. Coming to the next area here, I'm doing already some validation. So I've saved a sales order. Now what I want to do is I want to validate some transactions that are being created as a consequence of this action. So what I'm doing here, this is a sales order entity. So intuitively, what can I do with sales order? Of course, I can query the lines that belong to the sales order. So intuitively, that's what you can do with the framework. You would call this lines API. That is a query, right? So every time you can query some multitude of objects on an entity, that will give you the query back the query. So this is the query object of the ATL framework, as you can see. And what that will give you the ability to query either for a specific, in this case, specific line with some specific API. You can say, okay, for with item. So all the things that you can set on the line, you can query for inside a query object. Or if you, or for example, you can just say, give me first one. So this is the first line, or give me a single one. So in this case, it would expect just to give you back the single one. Or you can say that we also have a second entity and a last entity. In case that you want to validate, you have two, you can say give me the first one and then validate that one, and give me the second one and validate that one as well. So calling the first entity will give you back the entity sales order line. What can you have on the lines? Of course, intuitively, you can have transactions on the line. So then we created an inventory transaction API for you, and this will give you the query. So you can query over transactions that are created for this particular line. So you can see how intuitively you can create this API, and you can know exactly where these transactions are coming from. They're coming from the first line for this on this sales order. So I mentioned the queries. You don't. The other kind of purpose of the queries is to use them for validation purposes. So here I want to, and you have various different assert APIs here. So assert expected line set. In this case, I'm asserting exactly the lines that I define further up here through specifications to exist. There's assert contains. In that case, I only care that this transaction exists. Among the transactions, I don't expect, I don't care that other transactions exist in the system as well. There's also assert count. You can assert the count of transactions if that's what you care about. And you can also assert either a set of lines or just a single line. So it's very flexible as to what you want to validate on. In this case, I'm asserting that I expect below exactly these and only these transactions to exist, and a set of them. In this case, I have one, but you can use the set to, so in case you have more than one to use for, in case in the future, the changes, you can just add another spec. You don't have to change the set here. So I'm instantiating as a collection of specifications. So here we come into the specification concept of the ATL, as I mentioned earlier. What is the specification? Specification, again, is just your definition of expected behavior. So in this case, I expect, and I'm calling the add spec on a collection object, where I'm invoking exactly this transaction in this state to exist at this point of the test. Specifications, how do I invoke them? Inventory transactions, these are the feature level data class. So specifications for a particular entity exist on that feature level's data class. So that's how I would define them. I would call a spec class. It would give me that specific inventory transaction specification class. And then I can fluently combine exactly what I care about and what I want to validate. I can, and it's up to you. It's up to the author on what they want to validate. They don't have to provide all the API if they don't want to, or if they don't care. Let's say I only care about the sales quantity. Well, I can omit the other fields. I don't have to specify them. It's up to you. Really, it's offers quite the flexibility. But in this case, I care about all these 4 different things. So in this case, I expect the inventory transaction invent trans to exist with this specific item, with this specific sales quantity and negative sales quantity, and the status issue should be on order, and this specific set of inventory dimensions. Again, it's the same API as on the set on the entity, so it's has this consistency. I only pass the warehouse, the site will be defaulted for me. And when it comes to this point, the sales, the system will actually perform validation and give you a list of expected inventory transactions and list of actual inventory transactions that it will query the system and compare those two lists. And if they're exactly the same, it will not throw an error. In this case, I don't further filter my inventory transactions, so it will actually query all transactions. But since we're running this on a blank system, we only have one, then it will find one anyways. And that's the same here. We're only calling first entity because we only have one line created above on an empty data set. So just give me that first one. I don't care about anything else because it doesn't exist anyways. The next thing is the command. So here we have sales order. And what we're doing, we're invoking a post packing slip. Just like you would do in the system, you can post the packing slip there. And call the, you can provide what kind of update, what kind of quantity you want, type of quantity. In here is deliver now. Then when I do that command, I do furthermore validation. I'm grabbing a packing slip from the sales order entity. The packing slip journal is the query. And again, since I only have one packing slip that's posted, give me just the first one. I don't care. I know that only one exists, so that's just give me the first one. And that will give you back the packing slip entity itself. What can I do with the packing slip entity? Again, intuitively, each packing slip journal has packing slip journal lines. So then, of course, you would query for the lines. This will give you back the query. We're not restricting this query just like we're not restricting above. So that will query all the lines for this packing slip. And then the reason why I'm doing that is I want to validate the packing slip lines that I have. So again, following here, I'm asserting exactly these packing slip journal lines to exist. Again, I'm calling specification on a packing slip line. What's a packing slip lines? It's a data class coming from the invent domain area. And here I'm again calling with these specific things, with this item, with this ordered sales quantity, with this received packing slip quantity, and with these inventory dimensions. I can it's flexible, so I can either add or omit anything that's possible to be set on a journal line. That's exposed for you in specification. Then I perform another validation here. I go through the lines for the sales order. Give me the first one. Give me all the inventory transactions in a query, and assert or validate exactly these transactions that I expect at this point in the system. So in this case, I'm validating 2 transactions. The first one with this now should have a status issue deducted with a negative packing slip. Remember, I posted now packing slips, so that's why I have additional transaction. And it's pretty self-intuitive with this status issue with this same inventory dimensions. And the second one should have packing slip remaining quantity, same item, and status issue should be on order. So when it comes to this point in the system, in the test, the system will actually, the ETL will query all the actual lines for this inventory transaction for this sales order line, and compare against these 2 expected, the list of expected, which are these 2 ones. And if they match in all the different things that we've defined, and if there's no additional ones that are different in the actual versus expected, and vice versa, then it will actually pass and continue. What we do next is we do the post invoice command on the test. Again, this is a command. It intuitively resides on an entity of the sales order, because that's what I can do with a sales order. I can post an invoice. And again, it provides the API that allows you to specify what quantity I want to pass in, right? Sales update, just like it is on the UI where you specify. You can either put all or packing slip. In this case, we posted a packing slip in from previous command. So I expect the packing slip quantity to exist, and that's what I want to post on exactly. Then I'm doing the validation. Sales order is an entity. Invoices is a query. Query resides on an entity because intuitively I can query for invoices on a sales order, just like I can do in the system. I can do in our ATL framework as well. And again, here, give me just the first entity. I only care about the first invoice. I know that only one exists at this point in the system anyways, because I'm running on a blank data set. I only posted one invoice. So just give me first one because I know it only one exists. What that will return is will give me back the customer invoice journal entity. Why am I getting the entity? Well, because I want to validate some data again. What can I do with invoice? I can query the invoice lines. So each invoice has, of course, invoice lines. So intuitively, you would expect the ability to query for across the lines of this invoice. And that's exactly what this lines API give you. What that will give you back, it'll give you a query of invoice journal lines. Here, again, if you had more involved invoice with multiple lines with different quantities, items, you can restrict this query further. But here I know that I only have one line, so I don't restrict this query. So it will actually go and filter all the lines for this invoice, which means that and then I call this exert expected line set, similar as in the past. I expect at this point exactly this set of transactions, no more and no less, to exist in the system, and it will compare this list against the actual list by querying the database for this invoice journal line and compares those lists. In this case, there's only one, and with these specific things that I set. Where's this specification document? The specification object again resides on the feature level data class for journals. So you would go to do invent invoice lines, and that's where you would get the invoice lines, and that's calling the spec on the feature level data class will give you the specification object, which you can further in a flexible manner define what you want to validate and what you care about at this point. And then the last thing is at this point we've seen a few times already. So I want to validate the invoice, and I want to validate the inventory transactions at each state of the test. So now I'm posting an invoice. I expect some changes in my inventory transactions, and I want to validate. So in this case, again, give me the lines for the sales order. Give me the first line. Query the inventory transactions for this first line, and assert exactly these transactions to exist. I'm defining the collection and I'm adding these specifications, so these two expectations to expected lines to exist. How I invoke these specifications, I invoke the inventory transaction data feature level data class and invoke the specification and define exactly what I want to validate. In this case, this item status issue should be now sold, so it's changing. So I expect that to be changed. And then I have also on order still existing there with the remaining quantity as well. So that's just one class, and that's how kind of the flow of the tests are. The next thing I wanted to demo is, let's say you as an ISV have some pre-existing data setup, right? So you're not running on an empty company, but you have some company or data area that in some data area in the system where you have defined some data already for validating your features previously. Well, ATL can integrate with that as well by setting up this sysdata test case dependency attribute on top of your test. You're telling systest framework not to run on an empty data set to create a new partition, a new company, but to run an existing partition and find this USMF company or the company name that you specified, and the ATL framework will nicely run on top of that. It's built on a find or create concept, so every time you invoke any defaults from the entities or your and you can pass inside the defaults the IDs that you expect to see from the company that you're running on. It will actually first try to query and find those items, and if it doesn't find them, it will create them for you. So it just nicely integrates with existing data as well, is the point I want to emphasize here in this test. So with that, I will finish the first demo and go back to my slides. And let's do a quick summary of what we have defined. So we have defined the root node, how you enter into the ATL framework using ATL data root node class, how you navigate these data class hierarchies. Remember, there's always a domain level data class, feature level data class. In this case, it's data sales orders. How you invoke the specific entity. Remember, it's on a feature data class. Sales orders you would, for example, call create default in this case. Commands, they exist on a sales order entity itself. And then I'm posting a packing slip in this case, and I'm specifying a quantity I want to post packing slip with. So you can see how intuitively it builds upon itself, right? Queries, I'm using it for querying, for validation. In this case, I'm querying the journals and just give me a first journal. In the second case, I'm querying the packing slip journal for all the lines across this packing slip because I want to validate and assert something specific for these lines. Specifications, they reside on the feature level domain data class, feature level data class, and just invoking the spec where I can define my expected definition, expected object. And it works well together with the data fixture. And that's how you would use that there. So you might be wondering, okay, there's some ATL, there's a lot of these ATL entities, abstractions, but how do I create those? I have my own tables, or I want to extend system tables that already exist, but it seems like there's a lot of boilerplate code. Well, we have ATL Wizard. This is a code generation tool that will allow you to kind of create all that for you, so you don't have to. It will greatly simplify this generation of these objects for you. It will generate the entity objects, the query objects, and specifications objects. So that's the point of the ATL Wizard. So with that, let's jump into the second demo, where I will try to demo this wizard functionality. In here, I've set up a Contoso, some fictitious company, Contoso company. I'm in the business of assembling computer parts, and I need to purchase for that the electronic parts for my computer, and I really care about what regions they come from. So that's why I have already created an extension on the purchase table. I've added a couple of my fields in here, and I want to now be able to use ATL with my extensions. So how do I do that? The way you invoke the wizard is, let's say you created this extension. In the add-ins, you will see generate ATL query, specification, and entity. So this is where you would generate these three ATL objects for you. So let's go and generate ATL entity. It will go and open up this ATL wizard that you've seen a screenshot of, so that you can actually extend the base entity with your fields. So it's asking me what I want to extend it from. It finds an additional one just to use the base one. So here it actually recognized, okay, these are my fields coming from my extensions, and I want to add them both I want to expose them both. Here you have flexibility into the naming. If you want to name them differently than what the field it is, typically we leave that a default. Here, what you would fix is you would fix the naming to conform with our extension naming guidelines. The next thing you would set the destination in the model where you want this to be generated. So typically you would put your own model in here. So in this case, this is my model that I created for this presentation. You can preview what will be generated, what it will generate. It will generate the getters and setters. So parm methods for each field and set methods for each field. You can see it will actually nicely already create extensions that it is telling you that it's extending this base entity. So I'm okay with that. I just click generate. It asks me, okay, what project I want to add it. I have this project already open here, so just add it to my current project that I have it. No. So you can see it generated all this code for me already. Let's build it quickly. So I'm just going to build it. It's the same way you would do the queries and specifications, and for the time perspective, I've already done that up front. You can see if I open my solution, this is where my extension has been put, and I already done the same for query and specification. It's basically the same. It will allow you to expose the fields that you want to see, and same for specifications. And you would just invoke it the same way I invoked the entity, except you would use query and specification. So this has built successfully. So now I will go and change my test. So this is, I already created one test. Let's quickly refresh what the ATL concepts are. So here I invoked my data class. On the data class, I'm invoking the purchase order data feature level data class by calling the purchase domain and purchase orders, because that's what I'm interested in. Inside the purchase order data class, currently I'm creating a default one and saving it. You can either create default or you can just use init default and save. So to create the entity, the purchase order entity, just give me one in the system. On the purchase orders, remember I mentioned the way entities can reside either directly on a feature domain class for that base entity that you're querying, just like base specifications also reside on a feature class. But intuitively in the applications, just like you can in the application you can have queries on entity itself. For example, for the concepts that make sense to reside on that entity. For example, for sales order, you can have sales order lines query, so you don't have to invoke it by feature. So you can potentially stitch the code that way. But if I want to query entities themselves, those reside on a feature level. So in this case, that's exactly what I'm using. So on purchase order, I'm doing the query. And same with the specification here. Remember, now in this case, I only assert that it contains this line set. I'm not asserting the expected lines. I'm just inserting, okay, give me of all these purchase orders, query the purchase orders, and give me validate that this purchase order that I defined here exists. I don't care that it's kind of about the rest of them or the rest of the purchase orders, if they exist or not. I don't care. I only care that my purchase order exists. That's why you would use assert contains in this case. So let's add some of our concepts that we've now exposed from our extension. So I would, you have them in the IntelliSense. Sometimes IntelliSense will not show it right away, so don't worry about it. You know that it's generated if your solution has built successfully. To save some typing, I'm just copying from my finished test. So you can see how I'm setting my fields that I've exposed through my extension, just using the base entity nicely. I'm setting just the constants that I've defined above. I can do the same thing with a query. I can further restrict the query. For example, because I've created an extension for the queries, we have not seen this before, but this is how you would filter and kind of restrict down the query for a specific entity that you care about. In this case, I want to query all purchase orders for specific that have electronic part type chip, sorry, that would be the chip chipped constant, and for this region that I've defined up there. So this will actually filter down my query further. And in the purchase orders specification now, and this might be the most important part, is that you want to validate your fields that they are set correctly. So this is how you would do that as well. So remember, this specification is the spec purchase order, and we've extended that spec purchase order through the wizard. I've done that upfront, just like we've done for the entity. And it creates this with API that you can now validate, just like we've done in the previous example test. Now I can actually validate my own tests, my own API as well. So you can see how it nicely actually supports, and you can modify existing tests that you have, and you can supply your own fields from extension if you want to extend, or if you want to create your own entities on your own tables, you can do that. You can do that as well. So if we build this now, you can run this test. You can run these tests with specific extension fields that we are exposed. So you can see there was no boilerplate code. Everything was auto-generated for me. I just had to add a couple of fields, and it's very, very flexible, and minimal effort is involved. So with that, I will finish the second demo. Let's quickly summarize what we've shown here. In the second demo, we've shown how to extend entities, queries, and specification objects. Remember, right-click through add-ins on the table extension. That will open up the ATL wizard that will show you intuitively how to add these fields and expose them. You can preview generation code, you can rename things on the wizard, and you can specify the destination where you want generation to go. We reviewed the main ATL concepts in the ATL task that we had for my fictitious company. We've created an entity extension through the ATL wizard. You saw how easily that can be done. And I showed you that you can also do the same for queries and specification extensions. The same wizard will pop up and allow you to flexibly define. Perhaps you don't want to expose all fields. You can also pick and choose what you want to expose in the wizard as well. And finally, I've shown you how you can actually use these newly created ATL objects, fields from your extension, and add them to your test nicely. With that, I want to say that ATL is a very, very mature framework, as I mentioned earlier, and here are some numbers that you can see for all these ATL concepts in the framework. So we have over 900 entities in the system already, and if you there's more than 90% chance that you will find definitely already from the data that's in the system. You'll find a default or an entity. You can use the entity itself to control if you don't want to use the default in the test. So it should satisfy all your data needs for testing. So when can I use this? So the ATL framework itself is available in 10.02 already. The sample tests are available in 10.03, and the ATL wizard itself is available with 10.04. 10.04 update, which is itself. Yeah. And lastly, I want to point to a couple of links. We have documentation on our official Microsoft Docs site. It's under this link, and we plan on growing this documentation in the future as well. And the Yammer group is the next thing. So in case you have questions, feedbacks, in case there are things that I haven't covered, or you had lingering questions that weren't answered, if you have some feedback, or if you find some bugs, we created this Yammer group for you to kind of add that feedback there. And with that, the last thing I want to say is go start using this ATL today. It's quite mature. We've seen a lot of benefits, as I mentioned, and we want to share those benefits for you. And in this point, I'd like to ask some of the moderators if there's any questions that we've seen repetitively coming up that we could actually, or anything interesting insight that we have observed from the Q&A area.
Darren, there's no questions really that's not already covered in the presentation. So I think the only thing to highlight here is really, go start using the Yammer group if you have any questions. We'll respond to these. There is already a couple of posts around if the wizard can be used on prior versions than 1004, and there's a description on how to do that. So if you're looking for like doing this on a PU27 or PU26 environment, there is a way to kind of like do that.
Excellent. Well, with that, then I'll hand it off to you, Janice. I think we are finished. I want to thank everyone for kind of listening in and joining us our today's session.
All right, thank you, Davorin. All right, ladies and gentlemen, I'd like to take a brief moment here and bring your attention to a link that I posted in the Q&A panel. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference or have feedback on how we can provide you with a better event, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And that is going to conclude today's web conference. Attendees can access the web conference recording via the same registration link that was used to attend today's live broadcast. Please allow for up to 72 hours for that to become available. And I'd like to extend a big thank you to our presenter, Davorin, and our Q&A moderators, Michael and Henrik. And thank you, audience, for logging in and joining us today.